Now we will look at chapter 13, the periodic table, a very important chapter, and most of the time 2 or 3 questions usually appear in the exam from this chapter. So let's see what are the common mistakes which students usually do in chapter 13, and I will give you some tricks related to this chapter. First question, which statement describe the periodic table? Okay, so remember that how the periodic table is actually arranged. It is arranged according to the proton number. Some students get confused and they think that it is arranged according to the atomic mass. No, not according to the mass, only according to the proton number. Okay, so let's see one by one. The elements are arranged in order of their nucleon number. Again wrong, because this is the atomic mass, right? So not nucleon number. Let's see, the elements are arranged in order of their proton number. Yes, that's the right option. It is used to predict the properties of elements. Yes, why we have arranged the elements in a periodic table? Because it is helpful for us to predict the properties of different elements when they are arranged in groups or the period. So that's why this is the main function, or this is the main property of the periodic table. So that's why option 2 and 3 are right. So it means the option C is correct. Okay, so option C is correct over here. Okay, let's look at this question. Element P and Q have the same number of electron shells. Okay, so if they have same number of electron shells, we already know that in the periodic table, all those elements that have same number of electron shells, they belong to the same period number, right? So the period number is same if they have same number of electron shells. What does it mean? If any element belong to period 3, it means it has 3 electron shells. So what is actually period? This is the horizontal line is actually the period, and the vertical line is your group number. Okay, so this is group number and this is period number. So period numbers tell you the number of the electron shells, whereas group number tell you how many electrons are present in the last shell. If any element belongs to group 1, for example, it means in its last shell we have only 1 electron. Okay, so P and Q belongs to same period number. It means, okay, according to this information, they belongs to same period number. Okay, now let's see, an atom of Q has more electron in its outer electron shell than an atom of P. So let's make the last shell of the atom P and Q. So this is our Q and this is our P, right? So an atom of Q has more electron in its outermost shell. So Q has more electrons in its outermost shell. For example, we can just predict that maybe it has 4, okay? So P will have less, so it can have 2 or maybe 3. For example, this is our shell. Now we can answer these questions. So try to actually write whatever the information is given, and so you don't get confused, you have to first write that information, or you have to imagine that information. So because the imagination will not help you, so it's better that you use a pencil and write that information in a form of a diagram. So it will be helpful for you to answer such questions, okay? Now we can read the statements one by one. P and Q are in the same group of the periodic table. Wrong. Why wrong? Because if you see the last shell, they have different number of the electrons. So it means they don't belong to the same group. P and Q are in the same period of the periodic table. Yes, right, because they both have same number of electron shell. So they have the same period number, right? So this option is right. Let's see about the option 3. P has a greater tendency to form positive ions than Q. Let's see which one has the more tendency to form positive ions. Okay, so only metals can form positive ions because they have less number of electrons in their last shell. So which one has less electron in its last shell, P or Q? Of course, P. So it means P has a greater tendency to form positive ions than Q. So this option is also right. Let's see statement 4. The oxide of Q is more basic than the oxide of P. Q is more basic than P. Is this right? No, because basic means that should be a metal. Okay, so if Q has less number of electron in its last shell, then it will be more basic. Okay, so it means P is more basic. The oxide of P will be more basic than Q. So this option is also not right. So which options we are left with? 2 and 3. So it means the option C is the correct option. So this is how you can answer or tackle such questions. First, write this information in a form of a diagram or any other method that is suitable for you, and then try to answer such questions. Okay, let's see another example related to this chapter. Atoms of sodium, rubidium, and element Q each have one outer shell electron. So it means they all belong to group 1. So now they are asking the question related to group 1. Some properties of these elements are shown here. What is Q? So if you see the element, we have to check one by one the melting points. If you see the sodium melting point is higher, rubidium is lower. So after rubidium, we have another element that is Q, right? So we have to look for the elements in the group 1. So if you see the first option is hydrogen. Hydrogen also belongs to group 1. But why we cannot choose hydrogen from here? If you look at this, the melting point is 28. That is higher than the room temperature, right? So hydrogen is actually a gas. So it means this option can never be right because they are actually asking about the metals. So now you have to look the group 1, and after rubidium we have cesium or francium, right? So any one option can be right. So can you find any option that is cesium, right? So that's why option D is the right option. It's simple from here, but still you can look at over here because the melting point decreases down the group in group 1. This trend you have to remember. So in group 1, the melting point and the boiling point decreases when you go down the group, and density is increased because the number of shells are increasing, so the density of the metals will increase. So can you see here the density is increasing down the group. So that's why option D is a right option, that is cesium. Okay, so cesium is the right option, option D. Let's see another question. Which statement explain why sulfur has similar chemical properties to selenium? Let's see where sulfur is present and selenium. If you look at your project table, the sulfur is present in group 6 and selenium is also present in group 6. What does it mean? It means they both have same number of electrons in their last shell. And that's why, because the number of electrons in the last shells are same, and electrons are the particles that predict the properties of chemical properties of an element, right? Electrons are responsible for the chemical properties. So now the answer is simple, because they have same number of electrons in their outer shell, or you can say because they belong to same group number. So we have this option. Yes, they both have the same number of electrons in their outer electron shell. So that's why option A is right. So many students think that they both are non-metals, that's why their properties are same. No, carbon is also a non-metal, but if you see sulfur and carbon, both properties are totally different. Carbon usually makes giant covalent structure, but sulfur usually makes just simple structure, right? So the chemical properties are not same. It does not depend on the non-metals. If anything is a non-metal, mostly the physical properties are same for non-metals, but the group number or the electrons will actually decide the chemical properties of any element. These both selenium and sulfur have same electronic configuration of the last shell, so that's why their properties are also same. So option A is the right option here. Let's see question 28. Which statement about alkali metal is correct? Now you have to remember that there are two types of alkali metals. One is alkali and the other ones are alkaline earth metals. This question is related to only alkali metals. It means they are asking you about group 1 metals, okay? So group 1 metals are called alkali metals and group 2 are called alkaline earth metals. Let's see now one by one. Lithium is more dense than the sodium. If you look at your periodic table, lithium comes first and sodium comes later. The trend in the group 1 is that when you go down the group, the density increases because the number of shells are increasing. So lithium is less dense compared to sodium because sodium comes after lithium. So this option is wrong. Sodium is more reactive than potassium. Let's see where is potassium. Potassium comes after sodium. The density increases down the group and also the reactivity also increases down the group. So potassium comes after the sodium. So it means potassium is more reactive. Okay. Sodium is less reactive. Potassium is more reactive. So this option is also now wrong. C. Sodium has a higher melting point than potassium. Okay. The melting point decreased down the group. So if you see where is sodium, sodium is at the top and potassium is at the bottom of the after sodium, right? So sodium has high melting point and potassium has a lower melting point. So this option is the right option. Now they are in group 2 of the periodic table. This is the wrong. Why? Because alkali metals belongs to group 1. Alkaline earth metals belong to group 2. So I already have given you this answer. So what is the right answer? The option C is the correct answer. Okay, let's see another question. Elements in group 1 and group 2 show the same trends in their reaction with water and their density. Okay, what does it mean? It means if you go down the group in group 1 and 2, the density will increase. And what about the reactivity with the water? The reactivity of the with the water will depends. Okay, the starting one, because they are less reactive, so they will not react as like with the water, compared to, for example, like potassium. It will react vigorously with the water, but sodium, it will react slowly with the water. Okay, so reactivity actually is increasing down the group in both group 1 and group 2, and density is also increasing. So now let's see reaction with the water of barium and calcium. So barium, where is the barium? Barium is at the bottom of the group 2 and calcium is on the top. So what about the reaction with the water? Because the reactivity is increasing, so now the reaction of the, what will happen to the reaction with the water? The reaction with the water will be faster. Okay, so the reaction will be with the water will be faster for the barium, and density will also be higher. Why? Because the density is increasing down the group, so higher options are right. And what about the reactivity? Because reactivity is also increasing down the group for group 1 and 2, so the reaction with the water will be faster. So that's the option A. So option A is correct for this question. Let's say question 30. Which statement about elements in period 3 of the periodic table is correct? So now they are asking about the period 3. So you have to look for the horizontal line. Okay, so let's see the horizontal line, that is period 3. Sometimes the students forget about the period 1. They think that hydrogen is not a part of period 1. They count lithium as a period 1. That is wrong. In period 1, we have only hydrogen and helium. That is your period 1. Please don't get confused. The third period actually starts with sodium. Okay, so you have to look for the sodium period. That is the third period actually. Now let's see one by one. Aluminium is a non-metal in group 3. Aluminium, all the elements that belong to group 1, 2 and 3, they are actually metals, or maybe they can be metalloids. Okay, one or gallium is like a metalloid, but aluminium, of course, is a metal, so that option is wrong. Now let's see for argon. Argon is in group 8. Yes, that's right, and has 8 electron in its outermost shell. Yes, if you look at the argon, its atomic number is 18, so it means it has 2 electron in the first shell, then 8, and also in the third one it is also having 8 electrons. Okay, so how many? 18 together. So this option is the right option. If you want to look for other options, we can just look at that. Magnesium is in group 2. Can you see? Yes, magnesium is in group 2 and has 3 electrons in the outer electron shell. That is wrong. If it belongs to group 2, it means it should have 2 electrons in the last shell. Okay, so that's why this option is wrong. Sulfur is a metal in group 6. Again wrong, because all the elements that are present from group 4 to 7, they are all non-metals. So D option is also wrong. So we are just left with option B. So option B is the correct option. Let's see question 31. Which law describes the structure of group 7 elements and the trends in their reactivity down the group? So remember that group 1 metals, always their reactivity increases down the group. They are metals, but group 7 behaves just opposite of the group 1. Group 7 are non-metals, so their reactivity actually decrease down the group. This thing I already have explained, that why reactivity increase or decrease in my other video. You can check that video, that is related to must know material about the chapter about the paper 2. Okay, so you can just check that video and you will know that why the reactivity for the non-metals decrease down the group and for metal it increase. So now this is group 7. So the reactivity will of course decrease down the group. What does it mean? Fluorine is on the top, so it is the most reactive one. Whereas at the bottom you can find astatine, iodine, they are the least reactive one. So the reactivity down the group will decrease. So these two options are the right one. Now let's see about the structure. Group 7 non-metals are always present in a diatomic form in the nature. Okay, they are never present as monoatomic. For example, chlorine is never present in nature like this. It is always present like Cl2, fluorine F2, iodine also I2. So that's why they are always present in a diatomic form. So option B is the right option for this question. Let's see question 32. Astatine is below iodine in group 7 in the periodic table. Which row describes the properties of astatine? So to predict the properties of the astatine, you must know the properties of group 7 elements, okay? They are asking about the state at the room temperature. The state at the room temperature for the group 7 elements is actually their state will improve. For example, from gas, they will change into slowly to the solid, okay? So the first two, fluorine and chlorine, are gases, okay? And the third one is bromine, that is a liquid. That is the only liquid non-metal in the whole periodic table. You cannot find any other element that is a non-metal and it is also a liquid, okay? So we have only two liquids in a periodic table. One is bromine, okay, it is a non-metal, and another liquid is actually, you can find it for the metals, okay? There is only one metal that is actually I can check over here where you can find that one, mercury, okay? So the mercury 8G, it is a transition metal. It is present there. You can see it in the 1, 2, 3, 4, 5, okay? In the fifth period, 1, 2, 3, 4, 5, 6. In the sixth period, or it is in the, yes, in the sixth period, 80 atomic number, that is mercury, and it is also a liquid. But mercury is a metal and bromine is a non-metal, okay? So there are only two liquids in the periodic table and they are bromine and mercury. Mercury is a metal and bromine is a non-metal. Okay, now after bromine, we have iodine. That is a solid at room temperature. So after iodine, we have astatine. So we have to predict the property of astatine. So what does it mean? It means astatine will also be solid at room temperature. So solid options are right. Now let's see the reactivity. I already have told you that you have to remember the reactivity of the non-metals, and especially group 7, the reactivity decreases down the group. So what does it mean? If the reactivity is decreasing down the group, then astatine cannot displace chlorine, bromine, or iodine. Why? Because only the most reactive non-metal can displace the less reactive non-metal, right? This is the halogen displacement reaction, in which a most reactive halogen can displace the less reactive halogen. So, of course, this is the least reactive one, so it cannot displace any of them, chlorine, bromine, or iodine. So that's why option D is the right option for this question. Let's see question 33. Some information about an element of group 7 of the periodic table is shown over here. What is the element? Okay, this is just a simple question. You have to look for the melting and boiling points. So how you can find that which one has this melting? You don't need to memorize the melting and boiling points, but you just need to know a trick. So any element that has a boiling point more than 25, okay, and melting point less than 25, then it means that it is a liquid at room temperature, okay? And this one you have to remember. If anything has a melting and boiling point both greater than 25, that is a room temperature, then it will be a solid, okay? So now we can see which one of this is a solid or a liquid, okay? And if its melting and boiling point both are less than 25, then it is a gas. These are the tricks you have to remember. So if you see boiling point is 59, it means it is greater than 25. It is the boiling point is greater than 25. So these two options can be the right option. It means it can be a liquid or it can be a solid. Now let's see the melting point. Melting point is less than 25. But here the melting point should be greater than 25. So it means this thing is not a solid. It is only liquid. And we have only one liquid in group 7 that is a non-metal, okay, and that is bromine. So option C is the right option. Okay, so I hope this point is clear to you that we can choose now. So any element that has a melting point less than the room temperature and boiling point more than the room temperature, and the room temperature is specific, it is 25, okay, then that element will be a liquid. So option C is the right option. 34. Which statement about elements in group 8 of the periodic table is correct? Now they are talking about the noble gases. Group 8 means they have 8 electrons in their large shell. It means their electronic configuration is complete. They don't have to react with anyone. So now let's see, they have full outer shell of electrons. Yes, this option is right. They have full outer shell electrons. They are diatomic molecules. Wrong, because their shells, their electron shells The last shell electrons are complete, so they don't have to react with anyone. So they don't make molecule. They are just monoatomic. They are liquid. Again, wrong. They all are gases at room temperature and pressure. Noble gases. That's why we call them gases, right? Because all of them are gases. They all react with group 1. Again, wrong. They don't react with any of the elements because their electronic configuration is complete. So option A is the right option. Let's see another question related to group 8. Which statement describe the elements in group 8 of the periodic table? First, their atoms have full outer electron shells. Yes, this option is right. Their atoms have full outer electron shells. They are talking about the last shell, right? So the last shell is full. That is right. They are unreactive metals. They are unreactive, but they are not metals. They are usually non-metals. We call them non-metals, not metals. Okay. So this option is right, wrong. They are monoatomic gases. Yes, this option is right. They are monoatomic. They don't form molecule. So option 3 is right. They are diatomic. Again, wrong. Diatomic gases are only halogens. Halogens are the diatomic gases. The first two. Also the bromine, they are also diatomic, but it's not a gas. So diatomic gases are not, these are not the diatomic gases. So which options are right now? 1 and 3. It means option A is correct. Let's see which property of copper explain why it is classified as transition elements. Now let's see what are transition elements. These are actually the metals that have different oxidation state, because all the metals and non-metals in the periodic table have a fixed oxidation state according to their group number. But transition metals have not assigned any group number. If you look at your periodic table, they are in the center of the periodic table and no group number has assigned to them. Why? Because their oxidation state cannot be predicted. Their oxidation states are different because their last two shells are incomplete most of the time, so they can have different oxidation states, right? So that's why we call them transition element. Transition means that can change their state anytime. Okay, state means oxidation state, not the physical state. So they can change their oxidation state anytime. So that's why we call them transition elements. Now let's see. Copper can be bent into different shape. That is not the reason for the name transition. I already have informed you it's because of the oxidation number. Copper forms Cu2 plus and Cu plus signs. Yes, this option is right because it is showing two different oxidation states of copper. That's why we call copper a transition element. So option B is the right option. Let's see another question. Some information about 4 elements P, Q, R, and S is shown here. Which elements are transition elements? Okay, so to remember, first thing is that transition metals, you need to remember some of the properties of transition elements. And these all properties are actually what? They are physical properties. And this one is actually a chemical property. Okay, whenever transition metals make the compound, they will always be colorful. Okay, so transition metals always make colorful compounds. So if you see the chloride, the transition metal that will make the chloride salt, what will be the color? It should be colorful. So pink, purple, red. This option is right. We have to exclude now this option. Option B is wrong. Okay. Now we are left with density and melting point. Remember that among all the metals, the transition metals have the highest density. Transition metals have the highest density. And if you look over here, which one has the highest density? These two options have the very high density, but this one has a low density. So you have to exclude this option also now. Now we are left with just 1 and P and R, right? Now look at the melting point. So melting point of both of them are, if you see P and R, they both have a high melting point. So it means P and R, they can both be the transition elements because we have two options here now. So P and R, that is option A. So option A is the correct option. These both are transition metals. Okay, they have a high density and they have very high melting points because they are metals. And among all the metals, transition metals have the highest melting and boiling points and have very high density. Okay, and also they give colorful compounds. They themselves are not colorful except for copper and gold, but they will give you colorful compounds. All the compounds of transition metals are colorful. Let's see another question. Acidified potassium dichromate is used to oxidize ethanol. The ionic equation for this reaction is already shown here. Which properties of transition elements are shown here? So which one is a transition metal here? Of course, the chromium. Okay, the chromate. So chromium is a transition transition metal. So which property is shown over here? If you see, they both are reacting with each other, ethanol and acidified potassium dichromate. Okay, so they both are reacting with each other, and there is not the property of dichromate is not shown as a catalyst, that it is increasing the rate of reaction, because it is used in this reaction, right? The dichromate ion is used in this reaction and you are getting a different product. So catalysts are not used in the reaction, so it means it is not acting as a catalyst. So these two options are the right option. Variable oxidation number, yes, you can see a variable oxidation number in the reactant. For chromium, the oxidation number is different, but here it is different. It is 3 plus here, but if you try to find here for chromium, Cr2O7, okay, and the total charge should be -2. If this is 7 into 2 is -14, right? Then it means this should be +12. Then you will get -2, right? So the chromium oxidation state is 6 over here, because this is 2. So you can say +12, it is 6. So you see 6 changed to 3. So there are two different oxidation states of chromium that has been shown over here. It means it has a variable oxidation state. So that's why option C is the right option over here. Okay, so transition metal property, only the variable oxidation state is shown over here. Manganese oxide is a black solid. The equation for the reaction is here. Okay, the reaction produces a pale pink solution. Which properties of transition metal does this reaction shows? So these two are reacting with each other, manganese oxide and HCl. And if you see, the before it was manganese oxide, and now it changed to manganese chloride. So it means it's not a catalyst, right? Because the catalyst will remain the same at the end of the reaction. So this one don't act as a catalyst. Now let's see. They form colorful compounds. Yes, the colorful compounds is the option, can be the right option, because manganese chloride, if you see, the reaction produced pale pink solution. Before it was a black solid, right? So this option is right. They have high melting points and they have variable oxidation states. A variable oxidation state is a right option over here. They have high melting points. This option has not shown in this reaction. We already know that transition metals have high melting points, but here they are talking about the compound, right? And they have not shown you in this reaction about the melting point. So this option we cannot choose. In this reaction, we have to choose the option only. So O2, if it is here, is -2, it means Mn is here, it is -4 here, right? So how much is here now? This is +4, right? Now, what about manganese? Here, it is now +2 here with the chlorine. So it means now the oxidation state has changed. It has variable oxidation state. So this option is right. That is 2 and 4. So when 2 and 4 statement is right, it means option D is the correct option. So you don't have to answer out of the box, which is not like, for example, some student will choose the option 3. We already know that they have high melting points, but the question, if you see here, which properties of transition metal does this reaction show? So you have to answer according to this reaction. We already know that transition metals act as a catalyst, but this is not the property which is shown in this reaction. Okay, so your answer should be only according to this reaction. I hope this point is clear to you. Now let's see another question. Which compound is likely to be colored? Okay, so this is simple. All these compounds, if you look at them, we have metal in them and also non-metal. But for sure, if we know a compound that will be colorful, is for the transition element compound. So if you can see any of the compound that has a transition metal in it, then that compound will be for sure colorful. Okay, the other compounds can be colorful, but the thing is that for surety you are only sure about the transition elements. So this is the only compound that has a transition metal in it, that is manganese, Mn. So that's why option A is the right option, that it is likely to be colored. Okay, let's see another question. Which pair of the compounds show a transition elements in two different oxidation states? So these all, if you look here, chromium is a transition metal, copper, zinc, and also nickel. They are transition metals, but you have to find now their oxidation state. That is, if their oxidation state is same in both the compounds, then they are not showing the two different. They are not active. They are not showing as a transition elements, right? They are transition, but they are not showing two different oxidation states. So you have to find in which they are showing two different oxidation states. Now let's see over here. The simple trick is that you can see the number of the, what is the number here, the variable number. If the variable number is same in both, then you don't have to look in more detail. Chromium is 2 here and then oxygen is 3. Chromium is 2 here and the other ionic ion, that is sulfate ion, it is also 3. So it means they both have the same variables here, right? So you cannot choose this one. It means the oxidation state will be the same. Now let's see here. Here the copper is 2, but here the copper is 1 and there oxygen is 1 and here we have carbonate is 3. So this can be the option, right? Now let's see here. Zinc is 1 here, sulfur is 1. Zinc is 1 here and sulfate is also 1. So you cannot choose this option. Let's see about this one. Nickel. Nickel is 1 here and here it is 1. Here the nickel is 1. Here it is, this one is 2, right? So now these two options we can consider for B and D. Let's see which option is right, okay? So for copper, if you look at here, copper is Cu2 and oxygen is how much? Oh, so oxygen has the oxidation state of -2, right? So it means copper has the oxidation of state of +1 because we have 2 copper. So each one will be +1. So it will be cancelled. So we will have +2. So there, the oxidation state of copper is +1. Now let's see for copper carbonate, okay? It's simple. The carbonate ions, if you see here, the oxidation state of the carbonates have usually 2 as an oxidation state, okay? They have 2. So it means copper is +2 also here, okay? They both are cancelled. That's why we are not choosing here. So can you see copper has an oxidation state +1 here and here it has +2. Okay, let's see here now nickel. Nickel has an oxidation state of 2 here because why 2? Because if you see oxygen always have a oxidation state of -2. So this minus and minus was cancelled. That's why Ni was like this. Okay. So the oxidation state of nickel was +2 here and oxygen was -2. So it's here it is -2. Let's see for here. The nickel oxidation state, if you see the variables here is 1. It means this is the oxidation state of nitrate. Nitrate ions usually have an oxidation state of -1. But if you see the variable here is 2, it means the nickel was having an oxidation state of +2. So this oxidation state and this oxidation state is same. But in copper, the oxidation state has changed. In one, it was +1. In the other one, it is +2, right? So that's why option B is the only right option for this question. Let's see another example. What is the typical properties of transition elements? So the typical property is that they act as a catalyst. Why they act as a catalyst? Because they have different oxidation states. So that's why they can be used as catalysts. So option A is the right option.